Right, question 6. Some students are investigating the electrical resistance of different components using the circuit. And the components are going to be placed here in this box to be investigated. So we can put what we like in there, a light bulb, a resistor, a wire, whatever. Which row of the table is correct for both meters P and Q? So we've got a choice. One of them is going to be an ammeter or a voltmeter, and the other one is going to be an ammeter or a voltmeter. Now the key thing is, how are they positioned? Well, P is in the same loop as the component being investigated, so it's in series. Now an ammeter is always placed in series. Q is in its own loop, okay, around the component, so that's in parallel, okay, and a voltmeter is always in parallel. So P must be an ammeter, okay, and Q must be a voltmeter. So the answer must be B. Now one of the components being investigated is a 12 ohm resistor, and when you put it in the circuit, the ammeter reading is ½ amp. They want you to calculate the voltage reading. Now as soon as you see this, you should be thinking, right, I need an equation. The equation you need is voltage is current times voltage. Sorry, voltage is current times resistance. Those two values have been given to you. The current is ½ amp, the resistance is 12 ohms, so you get 1 mark for your working. And once you've multiplied them together, the correct answer is 6 volts. And the final page of the test, the students reduce the resistance of the variable resistor, and you've got to state what happens to the readings on each of the meters P and Q. Now they're only asking you to state what happens here, so it stays the same, it gets bigger, it gets smaller, but it would be nice if we could explain it as well. So let's go back and look at the diagram. So in the diagram here, we've got a variable resistor in series here with the component and the ammeter. If we make the resistance on this variable resistor less, then more current is going to flow through this circuit. So if more current flows, we're going to get a higher reading on meter P here, the ammeter. Okay? So the ammeter reading is going to increase. Also, if we decrease the resistance of the variable resistor, okay, it will have a lower voltage across it too. And let's say that the power supply is a 10 volt power supply. Then it should be that the two components, the variable resistor and whatever else is in here, should share that voltage. So for example, it could be this gets 5 volts and this gets 5 volts, or this gets 2 volts and this gets 8 volts. But the voltage across the two components must add up to the power supply. Now if the variable resistor is getting less resistance, it will also have a lower voltage. Okay, you could work that out from V equals IR if you wanted, okay, but lower resistance means lower voltage. So if this one gets a lower voltage, this component here, the one being investigated, the resistor at the time, this will get a higher voltage. So not only will P meter go up, Q will also go up. Okay, so the kind of answers I'm looking for is just to state this, but here I'm stating it and I'm explaining it too. The reading on meter P, the ammeter will increase, that's where you get your mark, and the reason for that is as more current will flow because you've got a reduced resistance in the circuit. And also the reading on meter Q, the voltmeter, is going to increase, okay, and that's because the component being investigated will get a bigger share of the battery voltage. Remember, that voltage is shared between the two of them, and if you lower the resistance of the variable resistor, you lower its share of the voltage. The students then reduce the voltage of the power supply. What will happen to the current in the circuit? Well, current is directly proportional to voltage for a resistor. Okay, the current will decrease because I is V over R. So if you decrease the voltage, you also decrease the current. Okay, and that will work for pretty much all components. Okay, but particularly for a resistor, if you remember, we said that a resistor obeys Ohm's law, and for anything that obeys Ohm's law, if you double the voltage, you double the current. So if you reduce the voltage, you're also going to reduce the current.